So the first person we have is Manuel Hatzl, who's talking about. Did I get your name right? I'm sorry if I pronounced it wrong. Who's talking about requirements traceability in Rust. And this is a talk that I'm especially excited about as somebody who's taught some software engineering. It's a topic you don't hear much about in the world these days, but it's absolutely critical to a lot of buildings. So I'm really excited to have your talk. Thank you very much.
Okay. I think the microphone works. Slides. Yeah, perfect. Okay, so hello, thanks for attending my talk about my project Mantra. It's an open source tooling for requirements traceability. Mantra is short for either managed tracing or Manuel's Anforderungstracing. And for those of you who don't know German, Anforderung is the German word for requirements. You may choose either one, but the managed tracing is more enterprisey and Manuel's Anforderungstracing more personal to myself because, yeah, as mentioned, my name is Manuel Hatzl. I'm from Salzburg, Austria, and since May I'm working as a tooling engineer at Ferris Systems. In this talk, I try to go through first with a quick what and why of requirements traceability, get you up on speed. Then usage flow, kind of top-down of Mantra, first defining requirements, tracing those requirements to code, linking test coverage and reviews of those requirements, and then collecting everything together and generate a nice traceability report. Okay, so let's start with requirements traceability. What is requirements traceability? Nice IEEE definition we don't have time for. Traces are those dotted dashed lines between requirements and artifacts. They representing kind of relations between them. Artifacts could be code, models, diagrams, whatever. And knowing and documenting those traces, that's kind of requirements traceability. I hope that's okay for you. Why I think about requirements traceability? Well, it's mandated or recommended by many safety critical standards, for example, ISO 26262 Automotive, DO 178C Aerospace. It can also help to automatically track project progress and status, which I quite like, and then it can also help to with change management, compliance verification, and software comprehension. Why did I create Mantra? Well, I wanted to keep better track of my own projects without much manual effort. And then for external people or myself a few months in the project, I wanted to better understand the project structure to faster get to a point where I need to go to fix bugs or implement new features. Then when starting out with Mantra, I couldn't find any open source alternatives that was able to trace Rust code and is built in Rust. And then lastly, because Mantra was part of my master thesis I did in collaboration with Infineon, and they wanted a tool that integrates well with their embedded Rust code and helps them with SPICE certification. Okay, so now let's see how Mantra works by starting to define requirements. There are at the moment two options. The simple one is on the left side, kind of markdown wiki, I call it. You define your requirements in one or more markdown files. This one is quite nice because you can define your requirements and then put it like in a GitHub wiki, so you have it directly next to your open source project. The alternative to define your requirements in following a JSON schema, this one is usable for exchanging requirements with other requirements traceability tools. The most important part here is those bold text. That's our requirement IDs, and those are used to uniquely identify requirements. You may also see that the IDs can also be used to represent and visualize a kind of parent-child relationship between requirements. So my ID.subID at the bottom is the sub-requirement of my ID. That's basic stuff at the moment. For tracing to code, Mantra's focus at the moment is to handle traces between requirements and code. So let's see how we can trace to code. You could also specify or add traces via JSON file, but I myself find it easier during development to manually add traces directly to the code following some Mantra pattern or tracing pattern. And for Rust code, I have three variants. At the top, you see an attribute macro rec. On the struct foo. Then on the bar field, you see a kind of an angle bracket pattern that's similar to the attribute macro. And then at the bottom in the foo function body, the recconf function macro. You can have the same name for rec and recconf because macros, to collect or to detect those traces in code. I use tree-sitter, so I pass the Rust code file by file and then walk through the generated AST to detect those traces. This means it's language specific for this approach, and I refer to it as the AST-based one. The nice benefit of the AST approach is because we can now link traces to whole code blocks, and this is quite useful later when talking about test and coverage, linking everything together. As you can see in this example, rec2 is for the whole definition of the struct and also for the function body completely just with one trace. Because it's language dependent, only currently Rust is supported. For any other language, and a text-based file basically, you can define the angle bracket pattern, and then I will search for it line by line via regex. This allows to, at the moment, basically trace in any programming language, and also configuration files, which is quite useful, for example, to add your requirement traces in CI/CD workflows to ensure tests are ran before your releases or so on. Talking about tests, let's see how test coverage and reviews are all linked to requirements. For this, I take again this Rust code sample before with the foo function, and now we assume that we have this test foo function, test foo1 test that is testing our foo function, and foo is traced to the requirement rec2, and we can now explicitly add the trace above this test function to like say that this test is testing this requirement and also this foo function. And now once we run and execute this test and collect statement coverage, we can like link the covered lines to the requirements that are traced to those lines, and this gives us collecting everything together like a confidence that requirements are actually covered by tests. Going one step further, we could now even decide whether we want to remove this trace, this explicit trace on the test function, and because if the test is still running the foo function, then the requirement will still be covered, or we want to keep the trace on the tests and then get the higher confidence to our tests that the tests are actually still executed or passing implementation code that's also linked to the traces, so kind of changing between. Then there are always requirements you cannot test or you cannot trace to one code section. So, or you want to additionally add like manual verification steps besides testing or automated testing. And this one with Mantra, you can define like your requirements in text files. And this combined with testing then makes requirements either covered by tests or manually verified or both. Okay, so now we have everything set together. Let's collect this and then we can generate the traceability report. For collecting, you run the command mantra collect in your terminal. This will look for a mantra.toml file in your current working directory, or the current directory, and then this will store everything in the mantra.db SQLite file. SQLite because SQL is nice to query lots of data, and you can store it in your project repository. Okay, so we have collected everything, and now to generate the report, you run mantra report in your terminal. You can choose at the moment between JSON and HTML. And as you can see on the image, this one is like a sample report of my pacemaker demo. It's available on mhatzl/pacemaker. It's like demoing of an embedded device to get traceability with Mantra. For the reports, the JSON one has a fixed schema to help with interop with other tools. For HTML, I use a Terra templating engine, which makes it quite nice to generate custom HTML reports, but I also provide a default template if you don't want to create your own template. Okay, that's it from Mantra so far. In the near future, okay, time is okay. I want to add being able to like set multiple parents for one requirement in the markdown approach, because for JSON it's already kind of working, but circular dependencies are a bit nasty at the moment. And JUnit and Kubertura having as test and coverage input would also be really nice, because they're more like standard, but this requires some database schema changes in the background. I'm currently looking into this one. Another requested feature was to be able to override test and coverage data in reviews in addition to just verify requirements, basically. To improve change detection, I also want to add hash information of requirements traces, reviews and so on, but I'm still not sure what data should go into calculating those hashes at the moment. Then for C and Python, I also want to get the AST-based tracing, because those languages are quite often used in safety-critical applications. Yeah, so having those with the AST-based one is quite okay, or quite important. Then for the long term, I would also like to have like integrated checks directly in Mantra and tailored reports for safety critical standards, so to help and reduce manual effort for certifications. Custom checks, being able to run custom checks in CLI would also be nice, so you don't have to write your own application just to query the data from the database. And then condition coverage in MCDC, again, something that's relevant for safety critical. Having MCDC information inside Mantra would be quite useful for the reports, but not sure yet how to store MCDC coverage, because Rust in MCDC is still a work in progress, so I don't know how this data will look. And then for the IDE extensions, I would really like to have like auto-completion of the IDs, or a documentation of requirements on hover over the traces. So if you, some of you has IDE and editor experience, please get in contact with me. And then, yeah, there are so many programming languages. I can't implement AST-based tracing all by myself. I tried to like generalize some crates to help with trace collection, but yeah, it's just takes time to integrate everything into Mantra. With that, that's it with my presentation. Thank you.